Hello and welcome to a video demo of the Energetiq Laser-Driven Tunable Light Source, or LDTLS. My name is Rob Meck and I'm a product engineer here at Energetiq. The LDTLS is a wavelength tunable light source that gives you high output in a narrow band. It's based on our LDLS, or Laser-Driven Light Source product, which offers high spectral radiance, high stability, and a long lifetime. There are a couple different versions of the TLS that focus on things like different power levels and different spectral bands. This is a Vis-NIR version that's based on our EQ-77 lamp head that gives you maximum spectral radiance. Here I have the TLS main housing, which contains the EQ-77 lamp head, as well as a monochromator for fast switching between wavelengths. This is the power supply controller for the EQ-77, a remote control switch that allows you to switch on and off the lamp head, as well as identify any controller or lamp faults that may be present, and finally a chiller for water cooling of the EQ-77. Let's turn this thing around and I'm going to show you a few different connections that we have on the back panel here. Let's take a look at the back panel of the LDTLS housing. The LDTLS features a fiber-coupled output, so I have an SMA optical fiber plugged in here. Here's the input for power, an output for USB so that we can interface with the monochromator in here using a computer. The controller cable that connects to the EQ-77 lamp head inside the housing. Inputs and outputs for water cooling, as the EQ-77 lamp head requires water cooling. And finally, a nitrogen purge input. We do recommend that you nitrogen purge our lamp heads while they're running for a long lifetime. For this demo, we're only going to be running it for a little bit, so we'll go ahead and leave this disconnected for now. Now we're going to switch on the EQ-77 lamp head. I've plugged in the power supply controller and switched on the chiller, which you will notice is conspicuously absent from the table because it's a little bit noisy. Let's turn our attention to the remote control switch here. So first thing, we want to make sure that there are no controller or lamp faults present. If there are, we're not going to be able to switch on the lamp head. Make sure that the interlock bypass is plugged in as well, because if it's not, it'll throw a controller fault. The next step, believe it or not, is just to flip this switch. Now, you may notice that the laser on LED comes on, but not the lamp on LED just yet. It's because there is some time that it takes to ignite the bulb. The principle of LDLS operation is that the laser focuses on where the plasma spot is going to be, and then the electrodes ignite the plasma. The laser then sustains the plasma to enable it to keep outputting broadband, high spectral radiance, high stability light. So it takes somewhere around 150 seconds for that to occur. So while we're waiting for that, a couple quick safety notes. The EQ-77 lamp head as assembled, as well as the TLS, are Class 1 laser products. However, the EQ-77 lamp head contains a Class 4 laser. So don't try to disassemble the lamp head. Also, don't try to run the TLS with the cover off, as there's a lot of high radiance light in here, a lot of UV as well. So, the lamp on LED came on just now. Can you believe it? What timing we have here at Energetiq. We're going to now turn to the computer interface to see how we can control the monochromator to switch between wavelengths of light very quickly. Now we're going to operate the LDTLS using the control software package. There's also a dynamic link library API if you want to write your own code. For this demo, we're just going to go with the prepackaged software. So I open up this lovely GUI right here. And first thing to note is it automatically recognizes the serial number for the monochromator in here that I have connected to my computer via USB. So that's great. We just hit connect. Once we connect, we're going to have to initialize the monochromator. If it's a little quiet in the room, you're going to be able to hear a little noise as the monochromator initializes itself. And first thing to note here is the filter wheel. So there is an order sorting filter in the TLS. So with the filter wheel, position 1 is closed, it's like shutter closed. Position 2 is open, and position 3 engages the order sorting filter. So in the Vis-NIR unit, we have a long pass filter at 600 nanometers. I'm going to keep it at position 2 for now, and I can go to 450 nanometers, let's say, for a nice bluish purple color. Looks really great, right? Bold. It's bold. If we want a bright green, I could try 550 nanometers. And if we want, let's say, another bold color, a magenta, that would be great for an accent pillow, but not maybe to paint your whole wall this color, then that's what we go at 650 nanometers right there. So if we want to try a scan, right? Say we want to step to a bunch of different wavelengths and add some hold time, some pause time for data collection. We can go over here to the scan menu, and I'm going to scan from 400 to, let's say, 650 nanometers. Let's keep it within that visible range for the folks following along at home. You're going to be able to see it on that piece of paper. Let's do a 25 nanometer increment, just so that we're able to see the color change as we do each step. And I'm going to do, say, 500 milliseconds for acquisition. So what this is going to do is it's going to start at 400 nanometers, wait half a second, right, 500 milliseconds, step 25 nanometers, wait 500 milliseconds, step, wait, and we can set these parameters, of course, to be whatever we want within the range. So the order transition is automatically going to happen at 600 nanometers. That's the wavelength cutoff for the long pass filter. But we can set it to be anything if we want. So for example, this scan is going to scan from 400 to 600, then switch the filter wheel position to engage the order sorting filter, and then do the rest of the scan from 600 to 650. If we didn't want the order sorting filter to engage, we could put in whatever number we want here, maybe a number that's outside of the range that we're scanning in, so that doesn't happen. But we'll just keep it in there. All right, so let's go ahead and hit scan. And watch the magic happen. That was the filter wheel change right there. So you might have noticed a slight delay for that to occur. But that's how you operate an LDTLS using the control software.